All right, good morning, everyone. This is Classwork 16 Honors, solving continuous compound interest equations. So the objective today is students will be able to solve exponential equations using the natural logarithm. So we're going to talk about what the natural logarithm is in a second, but first I want you to try the do now on your own. Solve the following equation for t. Okay, so hopefully you have paused the video and attempted this on your own. We did something like this in the do now in the last lesson. So what I would do, and it's okay if you did something different, but I would look at this and say, okay, I've got a base 10 here. That's awesome because that's the common logarithm. So I'm going to take the logarithm base 10 of both sides. And then, since I've got this here, I'm going to use my property of logarithms where I slide this to the front and I have t times the logarithm base 10 of 10 equals the logarithm base 10 of 250. And the logarithm base 10 of 10, we should know that 10 to the what power is 10? That's 1. So we get t equals log base 10 of 250, and I'm going to compute that in my calculator just for practice, since we are practicing that. So I'm going to put in first 250, and then I'm going to hit the log base 10 button right next to the 4. And I get t equals 2.398 if we round. Okay? And that should make sense because we're thinking, okay, 10 to what power is 250? We know 10 to the second power is 100. But 10 to the third power is 1,000. 250 is between 100 and 1,000, so 2.398 should kind of make sense intuitively. If it doesn't, please feel free to shoot me a text and we can talk about it. Okay, so this is something we were doing before school ended, where if we have a base 10, we do log base 10, right? Now, what happens if I have something like this? E to the 10th equals 250. Okay, so remember, E is that special Euler's number, okay? So really we would want to have a log, so this is a base E, so we want to have a log base E of both sides, right? That would make sense. Now, the log base E is a very special thing. This is called the natural logarithm. And we express the natural logarithm, we actually write ln, okay? Now I'm writing a cursive L so that you don't think I'm saying 1n, but it could be like ln, like that as well, okay? So when we solve this equation, we would take the natural logarithm of both sides. So the natural logarithm, this is ln, so I would take the ln of e to the t equals the ln of 250. And then I would have t times the ln of e equals ln of 250. And the ln of e, so really we're thinking, okay, base e to what power gives me e? That's going to cancel out just like log base 10 of 10. Those two things canceled out. Ln will also cancel out. And t will equal ln of 250. And we go here in the calculator, I put in 250, and then right next to the log base 10 button, there's the ln button. And I guess they don't do a cursive L, but I like to do a cursive L just so it's a little bit clearer. So then I hit ln, and I get 5.521, which we're thinking, remember, E is 2.718. So 2.718 to the 5.521 should give us about 250, and I can check that. 2.718 to the 5.521 should give us almost 250 equals, oh, did I mess it up? 2.718 to the 5.521 equals, okay, perfect. We're about 250 here. Okay, so what we're going to be using today we're going to be looking at continuous compound interest equations. So that's where we have the E, and we're going to be solving these by using the natural logarithm of both sides. Okay? So let's take a look at the first example and see if this starts to make a little bit more sense. Okay? So, example number 1. Phyllis deposits $3,000 into a retirement account that has a 6% interest rate that is compounded continuously. How many years will it take for Phyllis to have $5,000? Okay, so we're going to think back to last week's lesson, and we know that if something is compounded continuously, we're going to be using the P e to the RT formula, right? So we call that PERT sometimes. The PERT formula is our compounded continuously formula. If you need to, please go back to lesson, it's CW14, and review PERT before doing this if you haven't already. Okay? So, now I'm going to circle my other values and underline our question. So they want to know how many years will it take for Phyllis to have $5,000. So if we want to know how many years is always going to be our T value. And then I'm going to circle my 6% interest rate and deposits $3,000, and then we also have this number $5,000. Okay, so I'm going to be trying to figure out where do each of these numbers go in my continuously compounding interest formula. Okay, so if we remember, F is going to be our final amount. So what number would be our final amount here? 5,000, right? Her initial value, P, she initially deposited in $3,000, and then we've got a 6% interest rate, so that's got to be R. And remember that 6%, we are always dividing 6 by 100, so really our R is 0.06. Awesome, so I'm going to substitute all these values into my equation. So F, I'm going to have 5,000 equals P, 3,000, E to the 0.06 T. Okay, and I don't know T because we're trying to figure out how many years will it take. Now, just like in lesson 15, I want to isolate my exponential expression first before I take the logarithm of both sides. So I'm going to divide both sides by 3,000. Okay, so then 5,000 divided by 3,000. I don't think that's going to be pretty. Yeah, it's going to be 1.6666666666666. I'm going to round that to 1.667. And I still have e to the 0.06 times t left on the right-hand side. So now I've got a nice exponential expression, and I'm going to take the logarithm of both sides. Now, since I've got a base e here, that's what tells me I'm going to take the natural logarithm of both sides. Okay, so when I do that, I'm going to have ln of 1.667 equals the ln of e to the 0.06 times t. And what I can do here is use my calculator to do this side and my properties of logarithms to rewrite this. So if I take my 1.66666 and do the natural log of that, I get 0.51, and that's rounded. I'm going to leave it like that. And then here I'm going to slide my exponent to the front. So I'll have 0.06 times t times ln of e. And I know the ln of e will cancel out to just be 1. So I'm left with 0.51 equals 0.06 times t. In order to get t by itself, I'm going to divide both sides by 0.06. And I will get t equals, and I'm going to go to my calculator again, divided by 0.06. And I'm going to get t equals 8.5 about. And we know this is going to be years. So my answer here is 8.5 years. So this means that if Phyllis started with $3,000 and she ends with $5,000, and the rate is 6%, it'll take 8.5 years for $3,000 to get to $5,000 at a rate of 6%. Okay? We're going to do 2 more examples, and then you have some classwork to do on your own. So let's look at this next one. Stanley currently has $13,922 in his retirement savings account. He initially deposited $4,520 into the account 15 years ago. What is the interest rate in Stanley's retirement savings account? Okay, so let's underline my question. They say, what is the interest rate? So that's R. So we need to be solving for R probably here. Let me circle my other numbers. I've got 13,922 and 4,520 and 15 years ago. Okay, so let's look for keywords. So 15 years, 15's got to be time, T. Then initial deposit, that's got to be P. And if he's currently got this, that's got to be our final. Okay, so if my formula is F equals PE to the RT, I'm now going to substitute in my values from the equation. So my final value is 13,922 equals my initial value of 4,520 times E to the RT. So we don't know R, so I'm keeping R as R, and T is 15 years. Okay. So now we're going to be solving this just like how we solved our initial problem, except now we're solving for R instead of T. So what I want to do first is isolate my exponential. So I want to divide both sides by 4,520. And if I use my calculator, because I don't know that, 13,922 divided by 4,520 will be 3.08, if I round, equals E to the R times 15. Okay, now I can take the logarithm of both sides. And since I have a base E, I know I'm going to be taking the natural logarithm of both sides, just like in example number 1. Okay, so I'm going to have the ln of 3.08 equals the ln of e to the r times 15. And again, I'm going to use my calculator to actually figure out what is the ln of 3.08. And I'm going to use my value that's already in here and just hit the ln button. And I get 1.125 equals, and I'm using my properties of logarithms here, r times 15 ln times ln of e. And we know that this is really a base e logarithm, which will simplify to 1. So I've got, if I rewrite this up here, 1.125 equals r times 15. And I want to get r by itself. So I'm going to isolate r by dividing both sides by 15. So my 15s will cancel out, and I will be left with this divided by 15, 0.07499 equals r. Oops, 499 equals r. And if I simplify this or round, I'm going to have 0.075 equals r. And we know that if we want to have this as a percentage, so really r is 0.075. But to make this a percentage, I'm going to multiply by 100, and I should get 7.5% interest. Okay, so either of these answers would be correct. This is a decimal and this is a percentage, right? We're just expressing the same thing in different ways. Okay, so the steps are the same. We are using our formula, substituting in the values we know, isolating the exponent, taking the logarithm of both sides, and then solving for our variable or solving for our missing value. All right, I've got one more example for you, and then you're going to do some examples on your own in the Google Forms. okay? All right, our last example, number 3. Toby deposits $5,675 into a retirement account that has an 8% interest rate compounded continuously. How many years will it take for Toby to have $10,000 in his retirement account? Okay, now I do want to go back really quick. I just realized for number 2, we assumed it's compounding continuously. Okay, it did not say it was compounding continuous. It should have. I wrote this problem and I forgot to say assume it's compounding continuously. Okay, so I'm gonna write that in. Okay, so here we are. This one actually says compounding continuously, so we definitely know that we are using F equals P e to the RT. Okay, now we're going to circle our other numbers. So we have $5,675, 8% interest rate. How many years will it take for Toby to have $10,000? Okay, so how many years? Years is T. So it looks like we're solving for T again, just like we did in example number 1. Okay? So then, let's fill in our formula. So if we have a deposit of $5,000, that seems like the initial deposit. That would be P. How long until we have $10,000? That seems like the final. And then R is our percentage. 8 divided by 100 is going to be 0.08. Nice. So we've got 10,000 equals 5,675 e to the 0.08 times t. Okay, now we've already done one like this before, so what should we do next? We should be isolating our exponential expression, right, by dividing both sides of the equation by 5,675 to isolate our exponential expression. And when I do that in my calculator, 10,000 divided by 5,675, I get 1.76 about. Okay, what do I do next? I've got an exponential equation ready to take the log of both sides, right? And what kind of log am I going to take on both sides? The natural log, right? Okay, so we've got ln of 1.76 equals the ln of e to the 0.08 times t. And I'm going to use my calculator here. I've already got this value up. I'm going to hit ln. I get 0.5665 equals, and I'm using my property of logarithms, so what am I going to rewrite on this side? 0.08 times t times the ln of e. And what do we know the ln of e is going to be? Should simplify to 1. So I can cross that out, and I'm left with 0.5665 equals 0.08 times t. So how do I finish this? I'm going to divide on both sides. I want to get t by itself. So I'm going to divide both sides by 0.08. Use that in my calculator. And I should get 7.08 equals t. All right. And since we're talking about years, this is going to be approximately 7 years. So 7 years would be your answer. Again, in Google Forms, if you are pretty close or if you have just a rounding error and it marks you wrong, then I will go back and make sure I change your score to make sure you get full credit. Okay? Please, please, please contact me if you have any questions, and I look forward to talking to you later. All right. Bye.